Hello, 6th graders. We are starting Chapter 8, and Chapter 8 is about surface area and volume. Lesson 8.1 introduces you to solid figures because you're going to be finding the surface area and volume of solid figures. A solid is a three-dimensional figure that encloses a space. And a polyhedron is a type of solid whose faces are all polygons. So a polyhedron would not be a cylinder or a sphere because all of the faces on that figure are not polygons. Looking at the polyhedron in the picture, there are different parts of a polyhedron or a solid. So the faces are the flat surfaces of the polyhedron. So anything that's a flat surface is a face, such as what's shaded in red. A vertex is a point where three or more edges intersect. So I think of a vertex as a point or kind of like a corner. And the edges are the line segments where two faces intersect. Looking at this example, we're asked to find the number of faces, edges, and vertices of this solid. Well, this solid has a face on the top and a face on the bottom, a face, and then four faces around the sides. So there's a total of 6 faces. The faces intersect at 12 different line segments. So you have 12 different edges. I'll go over the edges in red here to point them out to you. So there's 4 on the top, 4 around the bottom, and then there's 4 along the sides. So we have 12 edges. And then the edges intersect at 8 different points, so we have 8 vertices. There's 1, 2, 3, 4, 5, 6, 7, 8. Let's talk about some specific types of polyhedrons we will work with in Chapter 8. The first one is a prism. A prism is a polyhedron that has 2 parallel, identical bases. And then the lateral faces, which are the sides, are all parallelograms. This one is an example of a prism. You have 2 identical parallel bases, and then all of the lateral faces are parallelograms. This one is a triangular prism. You name your prism by the shape of the base. So since the base is shaped like a triangle, this is a triangular prism. A rectangular prism would have 2 rectangular identical bases. You would just draw your 2 bases and then connect your corresponding vertices. So that would be a rectangular prism. A pyramid now is a polyhedron that has just one base. So your pyramid sits on one base, and then your edges come up to meet at one vertice up top. The lateral faces are all triangles on pyramids. And again, you name your pyramid by the shape of the base. This one's a rectangular pyramid because it has a rectangle base. You could have a triangular pyramid. A triangular pyramid would have a triangle base. And then you would just connect all your vertices. So that would be a triangular pyramid. So let's look at some information from lesson 8.2. In 8.2, we're going to start finding the surface area of solids. And the surface area of a solid is the sum of all of the areas of its faces. You can use a 2-dimensional representation of a solid that's called a net to help you find the surface area of the solid. Surface area is measured in square units, so either square feet, square yards, square meters. So a 3D representation of a figure looks like this. When you unfold it and flatten it, you get a net. And so the net shows you all of the sides of that figure just in a flattened version. It's kind of like when you have a cereal box and you collapse it down so you can put it in your recycle bin and make more room in your recycle bin. So this is called a net. It's a 2D representation of a solid. And to find the surface area of a figure, you're just finding the area of every face. So you would find the area of both sides. You would find the area of the back and the front. And you would find the area of the top and the bottom. And then you would add them all up, and that would be your surface area. So using a net is one strategy you can use to help you find the surface area. But you don't have to use a net. You can keep your solid in solid form and find the surface area that way. So looking at this rectangular prism, we notice that we have a front and a back. The front and the back you can't see. You have some dashed lines that indicate the back. And if I look at the front and back, the rectangle there, the dimensions of that rectangle are 9 by 5. So to find the area of this rectangle, I would do 9 times 5, which I know is 45. And there's two of them. There's a front and a back. So there would be two 45s. We also notice that on this figure, we have a top and a bottom. And on the top and the bottom, I need to figure out those dimensions. So this edge is 9. This edge is 6. So on my top and my bottom, I would do 9 times 6, which I know is 54. And there's two of those. And then we have our two sides. On the two sides, I've highlighted them in green. One part, that bottom edge is 6, and then this tall edge here is 5. So I would do 6 times 5 to find the area of that rectangle. And there's two sides. So now I'm ready to find totals for all of my surface area. On this part, you guys, I'm going to allow you to use a calculator. Okay? So I have 45 plus 45 for my front and back, which would give me 90. 54 plus 54 for my top and bottom would be 108. 30 plus 30 on my sides would be 60. And I'm going to use my calculator to add this up. And when I add 90 plus 108 plus 60 in my calculator, I get 258. And my label would be meters squared. So the first example was a rectangular prism. Now let's do a triangular prism. On my triangular prism, I have my two triangular bases. And remember guys, now these are triangles. So to find the area of a triangle, it's base times height divided by 2. So one triangle is right here. My base is 8.6 and my height is 6.3. This arrow is pointing to the height. So I'm going to have 8.6 times 6.3 divided by 2. And there's two bases. So I'm going to do that twice. So I'm going to use my calculator. And in my calculator, I'm going to type 8.6 times 6.3 divided by 2. And I get 27 and 9/100ths, or 27.09. And remember, I have two of those, so I could just do 27.09 plus 27.09. That would be my total of my bases. I'm going to go ahead and put that in my calculator. And I get 54 18/100ths for my totals of my bases. Now I have my lateral sides to look at. I have 3 of them. And sometimes my lateral sides are all equivalent, and sometimes they're not. So let's look at the lateral side. That would be the bottom of this solid. I'm just tracing it out in green. Our bottom would be 8.6 times 10.3. So I'm going to put that in my calculator. So 10.3 times 8.6 was 88 58/100ths. Now let's look at the side that's on the left. So right here, I'm tracing it in red. And for that, I would use 10.3 times 7.6. So I have different dimensions on that side, and I know that my lateral sides are not all the same now. When I type 10.3 times 7.6 in my calculator, I get 78 28/100ths. Now I have to look at my last of my 3 lateral sides, and I'm going to trace him in red also. And this bottom edge that's really thick in red, he matches up with this edge. So it's not labeled on that far side, but we know it would match 10.3. And then same with this, your tall sides here, they're going to match 7.6. So our 2 sides, our left and right sides are the same. They're going to be 10.3 times 7.6, both of them. It's just that the bottom was different. So in my calculator, I am going to add 78 28/100ths plus 78 28/100ths, and I get 156 56/100ths. So that's my total of my sides, which I have to add to my total area of my bottom and the areas of the bases. So I'm going to now add 88.58 plus 54.18, and my total surface area of this triangular prism is 299 32/100ths feet. So 299 32/100ths feet squared is my label. So I found the area of every face and then added to get a total. Alright kiddos, so we have done 2 examples of finding the surface area of prisms. And now we need to find the surface area of a pyramid. This one is a triangular pyramid, meaning that the base is a triangle. With your pyramids, you just have to pay attention to whether your base is a triangle or a square. This one's a triangular pyramid. I'm going to go ahead and find the area of my base. My base is this green down here. And sometimes triangular pyramids can get a little bit tricky because there are so many labels and there's arrows that are pointing to certain things. And you just kind of have to be careful about making sure that you have the right dimensions. So on my base, which is a triangle, so I'm going to have to do base times height divided by 2. This measure here is what I would call the base of that triangle, so 9. And then this red measure here that cuts across the bottom, the arrow's pointing at that, that would be 7.8, and that's labeling the height of that triangle. So 9 times 7.8 divided by 2. And you can tell that this is the base and the height because it forms a right angle. So when you see that right angle sign, you know that that's making your base and your height. So I typed 9 times 7.8 into my calculator, divided it by 2, and I got 35.1. So that's my base. So now I'm ready to find the area of my sides. So I'm going to look at this side right here that I'm tracing in blue because it's a triangle and it has the height labeled for me. The height is 7 and the base is not labeled, so I'm going to use the same measurement that I used on the other. So if this one's 9, then this one must also be 9. So I'm doing 9 times 7 divided by 2 because it's a triangle. I know 9 times 7 is 63. 63 divided by 2 is 31.5. And looking at my other sides, I'm noticing my other sides have the same dimensions. So I did 7 times 9 on that side. I'm also going to use 7 times 9 on this front side, right here. 9, and the height of that triangle is not labeled, so I'm going to use 7 again. And then same thing for that third side. So I have 3 sides that are 31.5. If I add those up, I get 94.5. So the total of my sides is 94.5. I'm going to add that to my base, and I get a total of 129.6 inches squared. If my base would have been a square, I would have had 4 sides to find the area of. But since my base on my pyramid was a triangle, then my pyramid had 3 sides. So just pay attention to the shape of your base. So students, we have done some examples of prisms and some examples of pyramids. Your homework for 8.2 is going to be all prisms. Your homework for 8.3 is going to be all pyramids. When you're doing your homework, I would like you to set your work up the same way that you saw me set my work up. So I labeled what I was finding the area of, and I showed my work. I did type my work into my calculator, which is perfectly fine. You can do that, but you do need to write your work down. You can't do this all in your head and in your calculator. So show your work in an organized way with labels like I did, just like I did in the video. You can use your calculator, and you can use a whiteboard or a piece of paper or Notability, whatever you would like to be your work page, because you don't have to hand your work page in, okay? If you have any questions, please email me, and I will see you later. Bye-bye.